All right, guys, thanks for watching the video. This is a video that you're going to use your worksheet and work with me for the first two problems, and then your job is to do the next two problems on your own. So these are the first two problems on the worksheet. Um, the other thing is, if you need a little more help and a little more repetition, this is in chapter 6-6 in your textbook. So feel free to look at all the examples in chapter 6-6. We learned before, and let me go ahead and make a new page. Beginning of the year, we learned that if you had an inequality, like for instance, 3x is greater than 9, and you had to solve this, you would divide by 3 on both sides, and you get x is greater than 3. And because there's only one variable, you'd graph it on a number line. So here's 0, here's 3. It would not include the 3, so it'd be an open circle, and you would graph it this way. Well, now, instead of having one variable, you're going to have two variables. And because you have two variables, you can graph it on a coordinate grid. And it's going to be done a little bit differently than how we used to do it. Well, the first step when you get an inequality with two variables, here's x and y, is you want to graph a line, which you're going to pretend for a second that this is not a greater than sign. It's like an equal sign. And you're going to solve this equation for y, meaning moving everything over. So if you add 4x on both sides, go ahead and do that, you are left with 2y is greater than, this cancels out, 6 plus 4x. I'm going to write it in slope-intercept form. So I'm going to write the 4x first. And last, you're going to divide both sides by 2, which means both terms get divided by 2. And you're left with y is greater than, 4 divided by 2 is 2x, 6 divided by 2 is a positive 3. So now that we have it in slope-intercept form, I'm going to go ahead and graph a line. Now, the issue you have to look for is whether this says greater than or equal to, because that's gonna make a huge difference. If you have to be greater than 6, it can't be 6. But if it was greater than or equal to 6, it could be 6. Well, when it says greater than, you're going to graph a line, but you're going to make sure the line is just dotted. If it says greater than or equal to, that's when you're going to graph a solid line. Right? And let me show you what I mean when I say dotted line. So let's graph a line as we would any normal. Here's the y-intercept, positive 3. So there's my y-intercept right there. And I'm going to use the slope, which is 2, which I can think of as 2 over 1. So I go up 2 over 1, up 2 over 1. And I'm going to go ahead and graph a line. But instead of graphing a solid line, I'm going to graph a dotted line. And please, when you're doing this, use a ruler. And what the dotted line signifies is pretty much the same thing as what this signified. When you had in the last problem, when you had an open circle, it signified that it has to be greater than 3, but it can't be 3. Well, this line says that you can have an answer. It's going to have to do with this line, but it can't actually be on the line. And that's what the dotted line represents. Now, the next thing you're going to do is because y just has to be greater than 2x plus 3, there's more than one answer that's going to work. So for instance, if y was 1 and x was 3, that wouldn't work because 1 is not greater than 2 times 3 plus 3. But, so, the point 3 comma 1 wouldn't work. That wouldn't be a solution. But if you switched them to 1, 3, that actually might, I'm sorry, that wouldn't work. If you did 1, 6. So if you plug in a 6 for y and a 1 for x, 6 is greater than 5. So the point 1, 6 would be an appropriate solution. But so would 1, 7. If you put in a 1 for x and a 7 for y, it would actually still make this inequality true. So there's more than one answer that's going to work, based on this original problem. So what we're going to do is we're going to shade. And what we do is we test a point. So I thought of the point 3, 1. And because this is not true, when you plug in a 3 for x and a y for 1, you end up with 1 is greater than 9. Well, that's not true. So where is the point 3, 1? The point 3, 1 is over 3 up 1 is right here. So this point right here is not part of your solution, which means everything on the other side of the line is part of your solution. So what we do is we shade in the entire part on the other side of the line. And what that does is it gives us an answer space. It gives us all the solutions that would work in the original inequality. Now remember, anything on the line will not work. But what we're saying is, if you take any point that's in the shaded area, for instance, this point right here, this is the point -1, +6. Let me write that down here, -1, +6. Because it's within the shaded area, if you plug the y of 6 in here and a -1 in for x, you will get an answer that is actually greater than 6. This will work in this original inequality. It also will work in this original inequality. Either this inequality right here is just the original one solved for y. So if you put a 6 in here and a -1 in there, this inequality is going to be true. If you plug this point in right here, that looks like it's point -8, 4. -8, 4, if you tested it by plugging it into one of these points, so I'll use this one right here. So y is 4, x is -8, plus 3. You get 4 is greater than, here is -16 plus 3, which is -13. And sure enough, 4 is greater than -13. So this point, -8, 4, would make these two inequalities true, which is why it's part of the shading. Okay. Let me show you another one. Let's say you had to graph the inequality y is greater than 4. All right. Well, basically, if you had the line y equals 4, we talked about how that's a horizontal line where every point has a y of 4. So that's a horizontal line right here. But because it says not only is it greater than 4, it could be equal to 4. Instead of doing a dotted line, I'm going to do a solid line. Well, for this problem, let's test a point. Now, there is no x, so we're not really worried about the x. All we're worried about is the y, and we need y to be greater than or equal to 4. So let's test this point right here. I'm just going to pick any point somewhere above or below the line. And if you pick this point is 2, 6. Let me write that down. Well, here, the y is 6. And we need it, if we plug a 6 in for y, we get 6 is greater than or equal to 4. Now, that is a true equation. That's true. 6 is greater than 4. So that means the side with the dot that worked will be the side that's shaded in. Now, had I picked this point right here, 0, 0, and plugged it in, the y here is 0. So if I plug in a y of 0 and I plug it into the inequality, you get something that is not true or false, which would tell you that this side would not be the side that gets shaded. It's this side that gets shaded, which we found out anyway. So I'm going to go ahead and shade in all the way up to the line, everything on this side of the line. Now, just so we know, any point in the shading, or because it's a solid line on the line, will actually make this inequality true. So it's part of our solution. Like that point, or that point, or that point, or this point, any of it will work. The only thing I want to warn you when you're going and doing the other problems on your own is please remember that as you're solving for y, if you have to remember the rules of working with inequalities. So as I move the x over by subtracting x on both sides, this is just a random problem. This isn't one on your sheet, but I want to show you something that's going to help you out. You get -3y is greater than -x plus 4. Well, in this problem, you're going to divide both sides by -3. So back in the beginning of the year, we reminded you that when you divide an inequality by a negative number or multiply by a negative number, here it's -3, you have to make sure you reverse or flip the sign. And then -1 divided by -3 is +1/3 x, and 4 divided by -3 is a -4/3. Just make sure that whenever you multiply or divide both sides by a negative number, you flip the sign.